In the first remote sensing lesson, you worked through unsupervised classifications and you were really relying on visual analysis. So with the second set of labs, you're going to be introduced to some other probably more quantitative methods of analyzing remote sensing data. So when we get the Landsat data, it comes with each pixel having just the digital number, the raw number, and you can't use any of the spectral indices like normalized burn ratio or the vegetation indices with just the DN. You need to be able to turn that into actual reflectance. And so the workflow is often the digital number to radiance, radiance to reflectance, and then you apply the index formulas. Radians is the actual energy or watts that the satellite sensors pick up for each ground pixel. And here's that just beautiful formula. The information related to the spectral radiance max and min and each band's max and min can be found in the metadata when you download the Landsat image. Then when you go from radiance to reflectance, again, this information is often the time of year, the day, the Julian calendar day is in the Landsat image, and then there are lookup tables for the others, and I'll provide a link to those lookup tables. But you just find this information and you're able to put it into your formula, and then when we use ENVI, we can actually manipulate the data to go from digital number to reflectance. In multispec, I don't know how that's done, and I can't see the algorithms or the programming band math or raster calculator aspect to do that. And from the literature review, it looks like that can't be done. You need to be able to do that to the data outside of multispec and then bring it back in. So most of the multispec data that you're doing in NDVI or the normalized vegetation index, the reflectance has already been calculated for you. So why do you do that? Well, you're able to get much more useful information. As I said before, with the classification, we were just kind of doing visual interpretation, kind of the art, and this moves you more into the science. One method is called band ratioing, and those are really able to look at those subtle differences that get masked by the pixel brightness. So for instance, if you're looking at a Landsat image that part of it's in the shadow of a hill, your reflectance is going to be a little difference based on that topography. But by doing band ratioing, you can see that if I look at band A in the sunlight and band B in the sunlight, my ratio is 96, and if I look at them in the shadow, my ratio is 95. So if I actually map the ratio, I'm going to be able to identify all the deciduous trees. If I'm just mapping unratioed data, band A is going to look very different if I'm looking at deciduous trees in sunlight as opposed to deciduous trees in shadow. One important indices is looking at stressed and not stressed vegetation, and this is the NDVI, or the workhorse index of remote sensing, and you should be able to do that both in multispec, and I know you can process that in ENVI. So I think in multispec it's the last lesson that I'm going to have you do. So it's looking at that ratio between the near infrared and the visible red. And so we had a discussion in class about, that really needs to be done at leaf on. So when you select your Landsat scenes, you want to make sure you do that at a time of year where you know the vegetation is in full foliage. In the fall, you're going to get much different readings. This is a great or a well-used indicator for large-scale projects over time, so you can average the NDVI and look at the drought indications over time. Now the Lab 2 for ENVI, we're looking at burn intensity, and so the ENVI product lets you actually do the conversions from digital number to radians and then convert to reflexance, and then use the normalized burn ratio on bands 7 and 4 to look at the project. Okay, that's not letting me move down. Hold on a sec. There we go. Okay, so that's the end. And then with the multi-spec, I'm going to have you guys for this lab to do 5 small short lessons that take you through stacking Landsat images, selecting smaller bands, clumping them together, and then going through a normalized vegetation index on the data. Okay, thanks.